Hello students, welcome for the new video. In this we are going to study Java Swings. Java Swings actually is a classes provided by Java for creating user interface. It has wide variety of classes to create user interface. Okay, so before this Java Swings, there was a technology called, there was another technique for developing this front end user interface was AWT. So we will see first what are the disadvantages of AWT, then what are the advantages of swings over AWT, then what are swings. Okay, so first disadvantages of AWT. The AWT defines a basic set of controls, windows and dialog boxes that supports a usable but limited graphical interface. See, in AWT we have limited graphical user interface, like we don't have any round buttons, we don't have any opaque buttons and all, transparency issues and all. Okay, and limited controls, limited user components. Okay, visual components. And another main disadvantage of AWT was it was translating those components to a platform specific equivalent. See, it translates its various visual components into corresponding platform specific equivalents. Means if you create a frame, suppose I have a frame here in this, if I create a button like this, if I run this code, the button will look like this because it is designed in swings. Okay, if you design the same button using AWT, there is no guarantee that the button's look and feel will be like this. The button will look and sometime appear like Windows button if the code is running on Windows. If it is running on Macintosh, it will look and feel like, button will look like a Macintosh button. Okay, if it is running on Linux platform, the buttons will look like Linux buttons. Okay, so you will ask, see, what is the problem with this code? If it is look like that, what is the problem? See, what happens is AWT components uses a native resource. They are referred to heavyweight. See, whenever a component translate itself to a platform specific code, we will call it as a heavy component. And what is the problem with heavy component is that first, because of the variation between operating systems, yes, one operating system is different from another operating system. Windows is different from Macintosh, right? And Macintosh is different from Linux. Although the Macintosh is built on Linux, okay, a component might look or even act differently on different platforms. It may look, you wanted some look for your app, but it is giving you different look on different platforms, right? So that will be a problem. Or sometimes that button will not appear, or that button size will be changed, or sometimes it will act differently for you. See, even act differently on different platforms. These problems will occur if you are using AWT. Because of these problems, they have developed Java Swings. Another problem was the second, look and feel of each component was fixed and could not be easily changed. So if it is converted to platform specific code for Windows or for Macintosh, the look and feel will be Windows or Macintosh. You cannot change the themes easily. Look and feel you cannot change easily. That was the problem with AWT. Third, last one, the use of heavyweight component caused some frustrating restrictions. If it is converted to heavyweight component, means to a platform specific one, at that time that platform may put many restrictions on those components. You cannot access this, you cannot access that. Okay, so I cannot explain all those things in this video, it will be lengthier. So we'll moving on to the features the Java Swing provides over AWT. And the two features were, swing components are lightweight, means the Java code will not be converted into platform specific code. See, in AWT, the Java code will be converted into platform specific equivalents, right? So at that time, we can say that platform independency is somewhat compromised, right? But in Java Swings, platforms are lightweight, sorry, not platforms, swing components are lightweight. They are not converted into platform specific one. This means that they are written entirely in Java and do not map directly to platform specific peers. Now, because lightweight components are rendered using graphical primitives, they can be transparent, which enables non-rectangular shapes. Here in the Java Swings, you can have non-rectangular shapes, opaque buttons, oval buttons, okay, and you can have some transparency also in those buttons. Okay, transparency, those who know Photoshop and all, they know what is this. Now, each component will work in a consistent manner across all platforms. So it is not like AWT where look and act will be different on different platforms. Here it will be acting same manner on all platforms. Okay, then what about the look and feel? See, Swing supports a pluggable look and feel. It is possible to separate look and feel component from logic of the component. Means if you change the theme of a Windows operating system, will it react differently to you? No. See, options will be same, right? Options will be same. If you press on start button, this menu will appear, right? So even though your theme is changed, right? So here, if your look and feel is changed, it will not affect the logic of the component. How it reacts, it will not be changed. Okay, so it is possible to plug a new look and feel for any given component without creating any side effects on logic. So if you change the look and feel, it will not affect logic. Okay, so what this architecture actually, all these softwares they are following is MVC architecture they are following. If you have a software architecture subject in future, you are going to study what is this MVC. So brief introduction about MVC. MVC stands for Model View Controller. Model means, here I will explain you MVC with an example. Suppose you have gone, you are into a restaurant and you have a menu in front of you. A menu is a view for you. Say, what do you want? If you want a burger or your juice, okay, that is a view for you. Okay, then you will have nice pictures on the menu, right? Then waiter comes to you and, may I take your order? He says, may I take your order? You will place an order, right? Then waiter will not prepare things for you, right? Yes. So here waiter acts like a controller. See, view determines how the component is displayed on the screen. Controller determines how the components react to the user. So what it will do, what the waiter will do, he will pass your request to the kitchen, right? In kitchen, your food is going to be prepared, and kitchen is your model, actual logic. What based on the request, what result should be produced. Okay, while the model is working, at that time model needs some data from outside. So in kitchen they will need items from fridge or store, right? So fridge and store will be our data, where data is stored. Same model will fetch data from database. Okay, so model view controller. Once your food is prepared, the waiter will bring back the results, the order, to your table, right? The same thing. If you are requesting for something onto your client system, then request will be carried out by the controller to the model, to the server. Then model will process the request and the results will be returned by the controller again. That is your, in your hotel example, restaurant example, waiter, right? So return to the user and displayed on the screen. So model means corresponding state information associated with the component. If the component's state information is changed, then what the result should be produced. Then who carries this information? Controller carries this information to the model. Then how a component, how the result should be displayed on your screen, it will be determined by your view. Determine how the component is displayed on your screen. So Java has changed this model to something called model delegate architecture. Java is not using your MVC, but instead of that they are using model delegate. In this, what happens is model is separated from view and controller. Means if you change the view, look and feel, okay. See, look and feel means what? See, this button looks like this, review button. See, review button looks like this. So when you press it, or when you press it, how it feels. See, when you move on this slideshow, it will give you something, right? Response, that it will be darker in color. Or suppose in your mobile phone, if you have a dialer, if you press any of the button, it feels like you are pressing one button, right? It will be pressed, then suddenly you release it, it will be embossed again, right? So here the feel, okay, look and feel, see, look and feel, look and feel are separated, view and control are separated from the logic. Okay, now after this we are having components and containers. Already I have told you that components in Java are individual things. See these buttons, toggle button, checkbox. See if I have this toggle button, see this button, this label, this radio button, see this radio button, this password field, this text area, this text fields, all those things are what? Actually components, and these components cannot be displayed on their own. Suppose a milkshake cannot be held on your hand. You need a container for that, a glass, a jug, right? So here the components will not be displayed on their own, they need to be placed on container. Okay, so we'll see. A Swing GUI consists of two key items, components and containers. All containers are also components. See, all containers are also components. What is this actually? See, in this I have these many components. See, this is my container, this is my frame container which holds components. Suppose I want to put components on that, so what I will do is I will create some panels. See, I have created one panel, then I will create another panel here. Okay, one and another one, two panels. In one panel I can add some elements like this, okay, right, then other elements on another panel. So you will see clearly this line, you can clearly see a rectangle shape, right? So I'm placing these components on this container. So this panel actually, this panel that you are seeing, this panel acts like a this panel actually acts like a component to whom? Component to this container, this frame that you have already seen, right? See, this panel acts like a component to this frame, this container that we had, right? So that's how all containers are also components. Component is an independent visual control such as a push button that we have already seen. A container holds a group of components. See, this container holds a group of components, and group of components are formatted text field, two formatted text field and one drop down list. Okay, so I will just revert back all the things. Okay, so thus all Swing GUIs have at least one container. See, you need one container. Okay, without a container you cannot display any component. A container can also hold other containers. Yes, see, now this frame is a container, right? So this container can hold this container. Panel is also a container. Now this container is held by this window. So another example that you have seen is that you might have seen in user components, tabs. See, tabs. Okay, tabs. Here I cannot show you, I need to add the tabs. So okay, any other options? Okay, we don't have, we will see later. So you will have one panel acts like a component on other containers. Okay, then a container can also hold other containers, yes, that we have already seen. This enables Swing to define what is called containment hierarchy, at the top of which there will be a top level container. So in this we had this panel, right? Inside this panel I can have another panel. See, I can have another panel. So on the top of this hierarchy, this is the frame, then another panel, then another panel, right? So at the end we have this panel, secondly we have this one, and lastly we have this frame, and these frame are top level containers, and this panel and this panel are called lightweight containers or low level containers. Lightweight containers or low level containers. See, this frame is a top level container which are called heavyweight container. Means these frames will be converted to platform specific code. At some point you need to, but rest of the panels will not be converted to platform specific code. Instead of that, they will remain in Java code. Okay, so this panel and this panel is not going to change its look in different platforms. Okay, that's why whenever we are creating a GUI in Java, we are first creating a frame, then we are putting panels. Okay, once you create a panels, different panels, see like this panel, then you place a these components look and feel will not be changed, okay, because these panels are lightweight components and these frames are heavyweight components. Now what are these components? Now in general, swing components are divided in J component class. So we have actually component class which is present in AWT. For differentiation, they have created a class called J component which is related to swings. What is AWT actually? Abstract Windows Toolkit. Okay, now in this, J component supports a pluggable look and feel. See, to create any swing components and all, these swing components are actually embedded into a class called J component, and J component class supports pluggable look and feel, and J component inherits AWT classes called container and component. J component inherits AWT classes. Those are container and component. We will ask that, sir, how this J component is inheriting two classes? See, actually J component is inheriting component, then component is inheriting container actually. Okay. Then we'll study about the containers. Components are very easy. They are derived from J component class and they support pluggable look and feel, and they are inherited from component and container class of AWT, because AWT was released first, then swing was released. Now we'll study about containers. Containers, there are two types of containers: top level containers and lightweight containers. Top level containers are those containers which are converted into platform specific one, right? In this I have shown you this frame is a top level container and this panel is a lightweight container which will not be converted into platform specific one, but this frame will be converted into platform specific code. If I run this code, so you will see that this panel has these two components and the entire frame, this look and feel, see these buttons will look like your Windows buttons, like, understood? So this is how top level containers and lightweight containers are. Now top level containers, these containers do not inherit J component. Why? Because J components are from swing and swing components are actually lightweight. So here top level containers do not inherit J component. Why? Because J component supports pluggable look and feel, but top level containers are platform specific one. That's why they doesn't support pluggable look and feel. Now see here, J component, this top level containers however have different layers. So these different layers are shown here. So whatever the frame that you are creating, whatever the frame that I have created here, this frame actually has this window. See this window, this frame has different layers, and those layers are, see, this frame, a frame, then a root pane. On that top of that frame we have a root pane, then we have layered pane. The layered pane, after that we have content pane, and this content pane will have menu and some title bars. See example here, if I run this, I will have this, see this logo over here, and you can have any text over here like this. See, a logo and a text, Java application 1 NetBeans 8.2 IDE 8.2, right? Text. This is called actually content pane, and content pane manages your components. And we will have at the end glass pane which will handle mouse events. Okay, glass pane for mouse events, which is transparent. Okay, now see, unlike swing other components which are lightweight, top level containers are heavyweight. Heavyweight means they are converted into platform specific one. Lightweight containers, they will not be translated into a platform specific one. They will remain in Java. So that's why they are inheriting J component. Lightweight containers are often used to organize and manage group of related components, because lightweight containers can be contained within another container. See, lightweight components. So this panel was lightweight component, right? So this panel cannot be contained with any other lightweight component or any heavyweight component. See, this panel, I can add this panel on this panel. Okay, see, I can add this panel on this panel, or this panel can be lightweight container, can be added on any heavyweight containers. Okay, and this actually, these things, these panels are used for managing group of components, Okay, now see, you have already seen in this, see, we have different panels here. So these are actually different tabs, which will have different components, and in this different tabs we have different panels. This is the panel, another panel. Actually they are not panel, they are separate lines. Okay, we'll have this different components on each tab. Okay, now we'll see what are the different swing packages available for you. Swing is a very large subsystem and makes use of many packages. So these are the packages available for you. So if you want, you can study on internet what these packages contains. Okay, we are not going to discuss all those things in this video. Okay, so we will move on to a program where we are creating two buttons and we are giving an action listener for that. So creating swing applet we are creating here. Okay, so we'll go on page number 872, program on 872. See, what we are going to do is, first user interface you are going to create here two buttons, alpha and beta. When you click on alpha, it is going to show alpha was pressed. If you click on beta, it is going to show beta was pressed. Okay, so let me show you first the output, then we will go for the code. Okay, so it is a applet. So I'm going to create a new class, Java class. So class name will be MySwingApplet. Applet that we have already created in the previous examples. Okay, but this time we are not using a AWT applet, we are using swing applet. Okay, so let me run it. See, we have two buttons, alpha and beta, and one text, press a button. When I just click on alpha, it will show you alpha was pressed. When I click on beta, it will show you beta was pressed. Again alpha was pressed, beta was pressed. So what actually you need over here, you need two buttons. One is alpha, another one is beta. Two buttons you need, and one text J label you need. One J label. Okay, so we'll see the code. See, here we need to import swing package. All swing packages we are importing. Then we are importing AWT package for event handling. So AWT packages, then we are importing AWT events for event handling. Okay, so this code is not needed because we are running in NetBeans. So if you are not using NetBeans, so there is another way to run this program. Okay, not like Java and all. Okay, we have different way. So I'm not going to explain that thing, it consumes time. So we'll see we have a public class called MySwing, which is extending JApplet. In previous example I have shown you applet, that was for AWT. Now JApplet is for swings. Okay, it is extending JApplet, and it is going to create two buttons. See, to create a buttons, you need to create an object of JButton class, JButton JBTN alpha, JButton JBTN beta. That belongs to, these two variables belongs to this class called MySwingApplet. Okay, and we need one label. What I have told you, what we need for this front end, we need two buttons, JButton 1, JButton 2, and one label. So here what we are doing, we are creating two buttons. One button is JBTN alpha, and how to create a button using a JButton class. So here you don't see any new, right, new object here. So it will be created further. Okay, see, JButton JBTN alpha, JButton JBTN beta. So these names can be given by user. This is user defined. Then we are creating one label. Then what we are doing here, I have told you that when you create an applet, it should have init method. First method will be init start, paint, stop, destroy. So in unit, what you are doing is you are creating a event dispatcher thread. Event dispatcher thread. Event dispatcher thread. Through event dispatcher thread, you are initializing your GUI. So how? See here, try swing utility dot invoke and wait. See, to create a event dispatcher thread, you need to call a method called invoke and wait, which is declared under swing utility. You can call invoke and later also. Invoke and later also. There is a difference between invoke and wait and invoke and later. The difference is invoke and wait will process one request, will not take another request until unless the first request is processed. But in invoke and later, all the requests are put it, are queued in a queue, then they will be processed one by one. Okay, means user will not be in a blocked state if you are using invoke and later. If you are using invoke and wait, once you have given a request, you cannot do other works. That request should be processed, means you will be in a block state, then you need to pass next request. Okay, so in this what we are doing is invoke and wait. You are using a method which is declared under swing utility class. Then you are creating here one anonymous inner class that I have already explained in the previous video, which is implementing runnable interface. How? You can refer previous video, which is implementing runnable interface. If it is implementing a runnable interface, what we need to do? We need to write the body for run. See, you are going to write the body for run. In the body of run, you are calling make GUI, right? Make GUI. Okay, we'll see where this make GUI is. Once a thread is created, while creating thread, if it shows any type of error, to avoid that error, we have included this calling for invoke and wait under try and catch. Okay, so this run calls make GUI, right? Make GUI, it is here, private void make GUI. See, it is private, so this class is not ended, right? So that's why the private methods can be called directly into the thread. So make GUI, what it is doing, it is first setting the layout, how the buttons will be arranged on the screen. Flow layout means what? Actually go according to flow, see, according to window size. So now the buttons is arranged like this: first button, second button, then the J label, right? If I reduce the size of this window, see how it will react. See, now the label comes to next line, then again I have reduced, then beta will comes to next line, right? This is according to flow, in linear fashion. Now after that, the buttons that you have created, you need to create the object of those buttons. So here you are doing jbtn alpha is equal to new button alpha. This will be displayed on the button. Okay, see here we have here alpha. Instead of alpha, we have alpha AITM. If I had alpha AITM, so on the button you should have alpha AITM. Okay, and while you are pressing, alpha was pressed. Okay, you can make here alpha AITM was pressed. Okay, so this is how you create a button. If you don't pass anything over here, button will not have any name. See, if you run it, button will not have any name. Okay, that's why you need to give a name here. Okay, see here. See, be careful that this is an object name and this is a text displayed on the button. Okay, so object name and displayed on the text displayed on the button. Okay, two buttons you have created, two different objects alpha and beta, and two different text alpha and beta on the different buttons. Okay, now for that button, if you press it, it should display what? Alpha was pressed, beta was pressed. So what you need to do, you need to register a listener for that. For that, what we are doing, J button alpha add action listener. You are registering a listener, and you are creating here anonymous inner class that I have already explained that in future we are going to use anonymous inner class. Anonymous inner class you are creating, which is implementing action listener interface, and action listener interface has one method called action performed, and you are going to write the body for action performed that takes action event class object as argument. So whenever you press a button, action event object is created and passed to this action performed method. Then what you are doing is, you are not using these objects directly. What you are doing is the label that you have declared now. For that label, you are setting the text that alpha was pressed. Understood? The label you are changing from press a button to alpha was pressed. See, the label was created here. J label, new label, press a button. Suddenly you press a button, its text changes from alpha was pressed to, press a button to alpha was pressed. Same thing will happen with beta button. See, same, add action listener, you are implementing action listener interface, then you are writing a body for action performed, but here you are writing, instead of alpha, you are writing beta. Then once you have created a button, once you have perform an action, what to perform, once a button is pressed, then you need to add these buttons to the frame, or a panel, whatever you have created, applet in our case. So we are adding these buttons to the applet in a manner how we have created. See, add alpha button first, beta button next, then label, right? If you change this order, then the display procedure also changes. Here, if I just add this button, J label, see, I will just move this first. Okay, now if I add this label after alpha button, what will this, how it will be displayed? First alpha button, then label, then beta button. See, alpha button, then label, then beta button. Okay, understood? So when you press alpha, alpha was pressed, beta, beta was pressed. Understood? So once you have added, then you close the class, close the make GUI method, close the class. Done. It's very simple. See, alpha, beta. Okay, so I will stop here. In next video we are going to study exploring swings. Okay, stay home, stay safe. Thank you.